Assalamualaikum and good day to Dr. Farida Hanim and Puan Liliwati. My name is Nurul Ani Shahira binti Kamarudin and my supervisor is Dr. Ilina Jaimi binti Muhammad Nordin. My title project is IoT-based semi-autonomous trash collecting system for inland waterways. Flash floods is most often caused due to extremely heavy rainfall from thunderstorms, just like what happened in Pahang and Johor currently. When our inland waterways are blocked by trash, flash flood will occur, which is dangerous to residents and contributes loss in economic factors. Thus, a prototype of semi-autonomous water trash collector has been developed for collecting the trash on water surface. The trash is collected by using a net that attached to the robot. Two DC motors are used to move the robot on water surface. The navigation is controlled using wireless communication and smartphone application. Type of trash that has been collected is small to medium size, for example, food packaging, plastics, and bottles. Future recommendation of this project is to use an infrared sensor, IR sensor, to detect the trash floating on water and improve the material used for developing this water trash collector. The objective of this project is to develop a prototype of semi-autonomous water trash collector for collecting trash in water surface. The second one is to construct GUI, which is the graphic user interface of smartphone application for controlling the navigation of the water trash collector using wireless communication. The third is to test and evaluate the performance of water trash collector in terms of its functionality, trash load capacity it can collect, and accuracy of maneuvering mechanism. As you can see here, there are various of water surface screening robot that has been invented, and most of them using a scooper technique to collect the trash. From the research, the largest capacity that a water surface screening robot can collect is 10 kg. The second one is modular floating rubbish trapper to trap the trash floating in the river. This is a big project, but it requires high cost for the maintenance because have to change the net every year. As for the third one, there are two main applications that are most commonly used to develop an apps for controlling the water surface cleaning robot. First one is Blink and the second one is MIT apps. So in this project, I decided to use MIT apps because it is easier and user-friendly. In this project, I use 5 electronic components, which is the Bluetooth module HC05, Arduino Uno, DC motor drive L298N, power supply 12 volt GP battery, two 12 volt 125 RPM DC motor. So the Arduino Uno and DC motor drive will be the controller, and the power supply GP battery will be the input, and the DC motor will be the output. The Bluetooth connects to the smartphone to control the robot. This is the flowchart of the methodology project. The first one, I start with the literature review and then propose autonomous water trash collector design, develop mechanical structure prototype for autonomous water trash collector, and then we test the ability of prototype to stay float and the ability to maintain, particularly orientation, assemble mechanical parts with electronic parts, and then develop graphic user interface in phone application, like I said just now, using the MIT apps, and then establish a wireless connection using the Bluetooth with our phone, with my phone, then develop system control for maneuvering and scooping mechanism. Scooping mechanism that I use is using the net that attached to the robot. And then I test control system, analyze data, and make improvement if necessary. And the project is done. These are the image of results that I have obtained from the experimental setup. The first image, figure 3, water trash collector, move forward from point A to point B within 2 meters. Figure 4, water trash collector, move backward from point B to point A within 2 meters. And for the figure 5, the robot turn right 90-degree angle. So the first image is the initial, and then it turn half, and this is the end of turning. Figure 6, robot turn left 90-degree angle. This is the initial, and then it turn half, and this is the end of it turning left 90-degree angle. I will show you the videos that I have recorded in the swimming pool and river and explain to you about these two tables, result for maneuvering in manual mode and result waste collected by manual mode.
The average time for the water trash collector to move forward from point A to point B is 9.796 seconds, while the average time of water trash collector to reverse backward from point B to point A is 10.747 seconds. The average time for the robot to turn right 90-degree angle is 3.31 seconds, while the average time for it to turn left is 2.84 seconds. The water trash collector able to move in the water surface of the river Sungai Pancho, but no trash were collected because the robot is unstable and I am afraid that it will fall into the river. It is recommended to use stronger and more water resistant material to protect the electronic components on the robot.
As a conclusion, a prototype of semi-autonomous water trash collector has been developed. The water trash collector was able to collect trash on water surface. After several experimental setups, it is proven that the navigation of the water trash collector is successful using smartphone application MIT apps. It managed to collect maximum of 192 grams of trash in pool area using manual mode. The type of trash that can be collected are small to medium size, which is plastic bottles and food packaging. Thank you so much for listening and have a good day.